Welcome to today's lesson, our learning target. I can investigate, justify, and apply reflections on the coordinate plane. In this section of this unit, we're going to be talking about transformations, and we're going to talk about our first transformation today called a reflection. All a transformation is a change in the position, the shape, or the size of a figure. So if you think about a reflection, what we're doing is we're changing the position of our figure. We're going to use lowercase r to represent reflection. And if you recall, when you've done this in middle school, another word for reflect is to flip. You're flipping over a line, and we're going to see where we end up today. So we have four cases here. We're going to start with the point 4, 2, and we're going to reflect as stated, and then we're going to plot the new point and state the coordinates. So we're going to start with 4, 2. We're going to reflect in the x-axis, which I already have highlighted. And the way you do that is you count the number of units from your point to the line of reflection. So it's 1, 2 units. So in order to reflect over this line, you're going to count 2 units in the opposite direction. So 1, 2. And the coordinate for this, if you go back to the origin, is going to be over 4, down 2. Reflection on the y-axis. So I've highlighted the y-axis. I'm starting with 4, 2 again. We're going to do the same thing that we just did for the x-axis, but now we're counting the number of units from our point to our y-axis. So I'm going to count the units 1, 2, 3, 4. So in the opposite direction, I'm going to count back for 1, 2, 3, 4. I've placed my new point, but I need to state the coordinate of that point. So I'm going back to the origin. It's -4 up 2. Now, this is where it gets a little bit trickier because a lot of students don't know where the line y equals x is on your graph. So what you can do is you can go to your graphing calculator. And you can go to the y equals button. If there's anything in there currently, you can just press clear to clear it out in y1. Now we want to type in y equals x. So here's the x key on your calculator. It's next to the green alpha. I'm going to type that in, y equals x. If you want to see what the line looks like, you can press graph. Now you want the points that make up that line. In order to find the points that make up that line, you're going to do second graph. And all we're going to do is plot these points on our graph so we can graph the line y equals x. So here's what that line looks like, in fact. I have the point 4, 2. I want to flip this over this line. So you know it's going to end up here somewhere. So if you were to do this, what happens is, we know we're going to end up here somewhere. It's going to be over 2 up 4. Now, what actually happens here, and I haven't gotten into this yet, when you reflect in the line y equals x, the point that you started with, or the coordinate that you started with, the order is reversed with the x and y value. So we started with 4, 2, and it becomes 2, 4. If I had started with 1, 3, then it would become 3, 1. We'll get to that in a second. You can also reflect in a line that's an x equals line or a y equals line. And students get confused between these. So I want to remind you, x equals is a vertical line. That means it's going to go up and down. And y equals is a horizontal line. That means it's going to go left to right. So in this case, it's x equals 1. So here's the line x equals 1. I want to reflect this point over this line, so I'm going to count the units. I'm 1, 2, 3 away. So I'm going to count 3 in the opposite direction. 1, 2, 3. I'm going to put my new point, and I'm going to find the coordinate for this point. Now make sure that you go back to the origin when you're trying to find the coordinate for this point. So if this is the origin, it's going to be -2 up 2. Now, a y equals line is a little bit easier because you can actually type in a y equals line on your graphing calculator. So I'm going to show you an example. Let's say instead that I wanted to reflect over the line y equals 2. Now remember, it's going to be a horizontal line. So if you go back to your graphing calculator, you go to the y equals, and you can type in, remember, clear whatever's out of y1. You can type in y equals 2 and press graph. So notice that the y equals line is now horizontal and it cuts through the y-axis at 2. So that's what a y equals line would look like. Now, a lot of students, instead of graphing, they like to remember the rules for each of these guys, the reflections, and there are rules for each of these. So we're going to state them here. We're going to see what happens. Remember, lowercase r is used to represent reflection, and we're going to start with reflection in the x-axis. What happens to your x and your y value? Well, recall that this is your x, this is your y. Now, we started with the point 4, 2, and we ended up at the point 4, -2. So what happened was we changed the sign of the y value to the opposite. We kept the x the same. So I'm going to come down here. We kept the x exactly the same. And we changed the sign of the y value. So it becomes x -y. Now, just so you know, this negative does not mean it's always going to be negative. It just means that you're going to change the sign of the y value to the opposite of whatever it was when you started. So if you were to come back up here, let's say that this was 4 -2 to begin with, and you reflected in the x-axis, it would become 4 +2. So again, that -y in the rule just means to change the sign of your y value to the opposite. Reflection in the x-axis. So again, we started with 4, 2, but we ended up at -4, 2. So if you see the pattern here, what happened was we now change the sign of the x, but we keep the y the same. So the rule for the reflection in the y-axis, we're going to change the sign of the x, but keep the y the same. I already talked about what happens with the coordinate when you reflect in the line y equals x. So we started with 4, 2, and we ended up at 2, 4. All we did was switch the order of the x, y. So we started with x, y, and we ended up with y, x. We didn't change the sign of either of these guys, so we're not going to put a negative with these. Finally, there's a rule that's not illustrated up here, and it's reflection in the origin. So I am going to plot a point, and I'm going to show you what it looks like to reflect in the origin. So let's plot 4, 2 again, and I'm going to plot the origin, which is 0, 0. So now I want to reflect over this point. And let's see where it's going to end up. It's going to end up down here somewhere. So this was 4, 2. We're going to end up at the -4, -2. And you notice that this is a reflection over this point right here. So we started with 4, 2, but we ended up at -4, -2. So what happened here? We changed the sign of the x and we changed the sign of the y, but the order remained the same. So we're going to come back over here. We're going to fill in the rule. Reflection, the origin, we start with xy. We're going to end up with a -x, -y. Okay, let's turn the page. Now, we just talked about what a transformation is. A transformation is a change in the position, shape, or size of a figure. Now, we have what's called an image point and we have what's called a pre-image point. So I'm going to add the pre-image right here. Now, the pre-image is the point that you begin with, the point that you start with. So in this case, 4, 2 is the pre-image. whereas the image is the point that you end up with after your reflection. So this was my pre-image, it's what I started with. This is what I ended up with after a reflection on the x-axis, so this would be my image. So pre-image is what you start with, image is the point that you end up with. And I said it's the point that you end up with after applying the transformation, which means in this case, our transformation was a reflection. So it's the point you end up with after applying the reflection to the point. We're going to go down to example 1. It says, given triangle ABC with vertices A, -5, 1, B, -1, 1, and C, -1, 7. We're going to graph this triangle on the axes below. Remember, when you are graphing, you should use pencil in case you need to erase. So let's plot -5, 1. We're going to call that A. Make sure that you label your points. B is -1, 1. And C is -1, 7. I'm going to take my ruler. I'm going to draw my triangle. Okay, so we're now finished with part A. Part B, on the same set of axes, we're going to graph A prime. This stands for prime. Now, prime denotes your image. This is what we're going to call our image point of A after we reflect in the x-axis. So we can no longer call, after we reflect this, we cannot call it A anymore. We're going to call it A prime, our image point. It's what you end up with after you apply the reflection. The image of triangle ABC reflected over the x-axis. So you have two ways to do this. We're reflecting over the x-axis. So you can count the units or you can use the rule. I'm going to do it both ways just so you can see. So let's start with A. We're at -5, 1. We want to reflect over the x-axis. Count the number of units. It's 1 unit to the x-axis. So that means it's going to be 1 unit away. We're going to call this A prime, our image point. And we're going to state the new coordinate for the image point. So it's -5, -1. Now let's apply the rule for B. We started at -1, 1. Let's go back and see what the rule says. Reflection on the x-axis, what's going to happen? We're going to keep the x the same, but we're going to change the sign of the y. So let's keep the x exactly the same, but we're going to change the sign of the y. So if we were to plot our new point, it would be at -1, -1. We're going to call that B prime, our image point. And finally, C, -1, 7. You can either count the boxes or you can apply the rule. I'm going to apply the rule. Remember, when you reflect in the x-axis, you're going to keep the x and you're going to change the sign of your y. I'm going to plot my new image point, -1, -7. I'm going to draw on my new image triangle and look to see if it makes sense. Does it appear that I have reflected this triangle over the x-axis? Yes. I flipped this over the x-axis and I ended up here. So this is your pre-image and this is your image. Down to part C. On the same set of axes, graph A double prime. We're going to call it double prime because what we're going to do is we're going to take the original points again, but now we're going to reflect over the y-axis. So I can't call the new points A prime, B prime, C prime because I've already used those. So we're going to add another prime here and call these double primes. So we're going to take our originals and we're going to reflect over the y-axis. So I've stated the originals for you. Now we're going to reflect these over the y-axis. So let's start with -5, 1. Now I want to reflect over the y-axis. So I'm going to do it both ways. I'm going to count the units first. We're at -5, 1. The number of units from here to the y-axis would be 5. So I'm going to count 5 in the opposite direction. 1, 2, 3, 4, 5. I'm going to put my new point, and remember, you're going to call it double prime. But we need to state the coordinate for this point. So here's the origin. It's over 5, up 1. Now, if you would like to apply the rule, here's what you would do. You start with B, which is at -1, 1. We're going to reflect in the y-axis. I'm going to look back at the rule. Reflection on the y-axis. You're going to change the sign of the x, but keep the y the same. So we're going to change the sign of the x to the opposite, and we're going to keep the y exactly the same. So if we were to plot this point, we would be at 1, 1. We're going to call it B double prime. And finally, for C, I'm going to apply the rule, although you could count the units. So remember the rule for reflection on the y-axis. You're going to keep the y the same, but you're going to change the sign of the x. So let's change the sign of the x, keep the y the same. We're going to plot C double prime at over 1, up 7. Call it C double prime. And we're going to draw on our final triangle. Again, determine if it makes sense. Does it appear that I took this and I flipped it over this line and I ended up here? Yes. Okay, moving on. Example 2. So what we're going to do is we're going to start by graphing this triangle with vertices 2, 3, 0, 6, and 2, 6. So again, use your pencil because if you need to erase, you can. So over 2, up 3, over 0, up 6, and over 2, up 6. I'm going to take my ruler, I'm going to draw on my triangle. Okay, down to part B, it says, graph and state the coordinates of triangle A prime, B prime, C prime, the image of triangle ABC reflected over the line y equals x. Well, remember from our front page what the line y equals x looks like. I'm gonna go back. Here's what y equals x looks like. Remember, you can type this in your graphing calculator to determine the points that lie in this line so you can graph this line. So I'm going to go back to my graphing calculator. I'm going to go y equals. I'm going to type in y equals x. Remember, the x is located next to the alpha. I'm going to press graph. Here's what the line should look like when I'm finished. Now, to get the values that lie in this line, I'm going to press second graph. And I'm just going to go through and I'm going to plot these points on my line. So we have -1, -1, -2, -2, -3, -3, -4, in the opposite direction, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. I'm going to take my ruler, I'm going to draw my line in. I'm going to label my line as y equals x. Now, a lot of students find it difficult, I'm just going to shift my A back up, to figure out where the points are going to end up after reflecting over y equals x, because you can't just count the units, because if you look, for example, from C, we would have to go from here to here. And we don't have full boxes when we go from here to here to count. So the easiest way to reflect over y equals x is to apply the rule. So I'm going to go back to the front page and see what the rule said. The rule said if I'm reflecting on y equals x, I'm going to switch the order of the x and y, but keep the signs the same. So that means what I'm going to do is I'm going to switch the order, but keep the signs the same. Switch the order, keep the signs the same. Switch the order, keep the signs the same. And I'm going to graph my new triangle. So 3, 2. I'm going to call it A prime. 6, 0. I'm going to call that B prime. and 6, 2, C prime. I'm going to take my ruler, I'm going to draw on my triangle. And there's what your triangle is going to look like, your image triangle, after you reflect over the line y equals x. Part C, we're going to graph and state the coordinates of a double prime, b double prime, c double prime, the image of triangle a prime, b prime, c prime, reflected over the line y equals 2. Let's go back to the front page. Remember, y equals 2 is going to be a horizontal line, and it's got to cut through your y-axis at 2. You can type this in your graphing calculator to see what it looks like. So let's go back here. I'm going to type in y equals, I'm going to clear this out, 2, press graph. So it's going to be a horizontal line cutting through the y-axis at 2. So here's my y-axis. I'm going up 2. I'm going to simply draw in my horizontal line. Oh, y equals -2. So I made a mistake. So I'm going to go back. I'm going to type in y equals -2. Now, the negative key is located down here next to the decimal point. So -2. I'm going to press graph. So it should be below the x-axis. So we're going to count down 2 on the y-axis and draw our line. Okay, first thing I'm going to do is transfer these coordinates down here. I'm just repeating a prime, b prime, and c prime. And there's no rule for this. So what you're going to have to do is you're actually going to have to count the boxes from a prime to the y equals -2 line, and then we're going to have to state the new coordinates of the image. So let's go to, make sure you're going to the right points, a prime. Okay, so for a prime, we were at 3 up 2. Here's the origin. So let's count from here to our line of reflection, and I'm going to highlight this so you don't get confused. So from a prime to our line of reflection, it's 4 units. So we're going to count down 4 units. 1, 2, 3, 4. We're going to put a new point there. We're going to call it a double prime. And let's see what the coordinate for a double prime is. Now make sure you go back to the origin before you state the coordinate for a double prime. So from the origin, it's over 3, down 6. Okay, we were at 6, 0. We want to count to the line y equals -2, so we're 2 units. So we're going to count down 2 units, put b double prime. And we're going to state the coordinate for b double prime. So what we want to do is go back to the origin. It's going to be over 6, down 4. And finally, c prime was at 6, 2. So I'm going to count the units from c prime to my line of reflection. It's 4 again. So I'm going to count down 4. 1, 2, 3, 4. I'm going to call it c double prime. I'm going to state the coordinates for c double prime by going back to the origin. So it's going to be over 6, down 6. I'm going to take my ruler. I'm going to make my new triangle. I'm going to move this guy over here. And we're finished. Now, we're going to talk about properties that are preserved. Another name for preserved that they like to use on the final is invariant. It means preserved or stays the same under a line reflection. Remember, we use lowercase r for line reflection. The first thing that's going to stay the same is the length of the sides. If you notice under a reflection, for example, let's count the number of units from B to C. The length of this side is 2. When you reflect, the length of the side remains the same. So the length of the sides do not change at all. So we say that distance or length remains the same under a reflection. Okay, the second property that's preserved would be angle measure. If you look at angle C, it's a 90-degree angle because we have a horizontal and we have a vertical. That forms a 90-degree angle. Does it still remain a 90-degree angle under the reflection? So let's look. We have a horizontal, we have a vertical, so it does remain a 90-degree angle. So angle measure is also preserved. Midpoint. If we have a midpoint on side BC, does that midpoint stay in the middle or stay as the midpoint of BC under the reflection? And the answer would be yes. And if you remember, we use capital M for midpoint. Parallelism. So the easiest way to show you parallelism is to think about a rectangle. So let's take a rectangle, for example, any rectangle. Now let's say I were to reflect this rectangle over the y-axis. My question is, the top and bottom are parallel. The left and right are parallel. Would they remain parallel after a reflection in the y-axis? And clearly the answer is yes. If all you're doing is flipping this figure over the y-axis, will the sides remain parallel? Yes. So we say that parallelism is preserved. And finally, the last one's difficult for students because it's a big word, it's hard to remember. It's called collinearity, which says if you have points that start on a line or a side, do they stay on this line or side under the reflection, or do they move around and move somewhere else? Well, if you notice, we have this side with B and C, and those points stay on that side under the reflection. So we say that collinearity, or points on a line, is also preserved. Okay, finally, I want to talk about orientation to finish off this lesson. So we have two types of orientation. We have what's called clockwise and counterclockwise. So orientation is simply the ordering of the vertices. So I'm going to show you what that means in a second. There are two types of orientation: clockwise, which I'm going to call C for short, and counterclockwise, which I'm going to call double C for short. Now, what we're going to do is we're going to go back and look at the ordering of our vertices and determine whether the orientation is clockwise or counterclockwise. So let's go back to our previous example. This is how you would find the orientation. We call the figure ABC. So you start in the order that they state the vertices. We start at A, and then we go on to B, and we go on to C. So if you notice, we're going in this direction. Now, would you say that this direction is clockwise, or, so that means the way that the hands move on the clock, or counterclockwise? Well, clearly this is in the clockwise direction. So I'm going to put C there. Let's look at what happens after the reflection. We formed our new figure called A prime, B prime, C prime. So we're going to go in order from A prime to B prime to C prime. Would you say that the direction or order of these vertices is going in the clockwise direction or counterclockwise? And in this case, it would be counterclockwise. So if you notice under a line reflection, the order of the vertices or the orientation is reversed. So if you had started with counterclockwise, it would become clockwise. So the order or the orientation of the vertices reverses under a line reflection. So my next question, is orientation preserved? Does it remain the same under a reflection? No, it reverses the order of the vertices. So there's my explanation. Now, a new definition called isometry. And what is an isometry? It's a transformation that preserves, remember preserves means stays the same, distance and angle measure. Remember, another word for distance is length of the sides and angle measure. So first of all, let's go back and determine if reflections are isometries. Under a reflection, do the length of the sides and the angle measures remain the same? So we've already talked about this. Do the length of our sides remain the same under a reflection? Yes, remember we counted 2 units, it stayed 2 units. Angle measure, we talked about angle C, that's a 90-degree angle. Does the measure of this angle remain the same under a reflection? Yes, it's still a 90-degree angle under the reflection. So in fact, would you consider a reflection an isometry? Yes. Now, we have to talk about the 2 types of isometry. We have direct, and we also have what's known as indirect or opposite or reverse. So under direct, distance is preserved and orientation is preserved. So my question, was distance preserved? It sure was. Was the orientation preserved? No, it changed. Remember, we went from clockwise to counterclockwise. So I would not say that, in fact, a reflection is direct because orientation is not preserved. Now, what happens with indirect or opposite or reverse? It still preserves distance, which means the length of the sides, but orientation is reversed. That would be the case for the reflection because remember, the length of the sides remain the same, but the orientation is reversed or changes. So what type of isometry is a reflection? Indirect. And remember, indirect is the same thing as opposite or reverse.